My name is Roy Braam. Some of you might know me. I'm as well in the Amsterdam Jug organization. I'd like to welcome you here at the ING. I think a great venue. Many thanks for the great food, drinks, and all the organization. So I think a round of applause for them. But well, you're not here for me. So let me introduce our first speaker, Tim from ING. Well, I think he can better introduce himself. So.
Okay, cool. Let's start. Yeah. Okay. Thanks, Roy. Oh, sorry. Okay. Good evening. Thanks for joining. Let's see if everything is working fine. Yeah, nice. Yeah, thanks for joining the meetup. Really great to be here. And today I'm going to talk about Kafka applications, streaming applications, and observability of those applications. So, yeah, let's get started. I did this talk with a colleague of mine at the Kafka Summit in London. Unfortunately, my colleague Kosta could not be here today, so I will do it today by myself. But let's hope the demo gods are with me, especially on the parts he did. But everything should be fine. Yeah, I'm Tim van Baarsen. Working at ING for around 5 years. Started in investments, moved to the central Kafka team. And my team is in the Netherlands, but also in Romania. And we are basically managing the Kafka clusters in ING. We're helping out teams. We do support. We do internal courses. We do a little bit of consultancy as well, because Kafka is heavily used in ING. Yeah, you probably know ING. We're a global bank, active in more than 40 countries, have a lot of customers to solve, and we're always looking for new talent. I think I can say we are front runners in Kafka. We started in Kafka around 2014 in production. At that time, it was still one of the first versions. So we have 8 years experience in running Kafka, operating Kafka, helping teams with Kafka. We currently have more than 6,000 topics in production. We manage different clusters in different countries. Yeah, and we are serving up to 1,000 development teams in their Kafka applications. Some of them are using it for heavy stream processing. Some are using it just to ship data around. Some teams are using it for metrics and logging. But it's heavily used. And we also have a self-service portal where people can request topics, give permissions to other teams to consume their topics. So teams are in control and don't have to create a ticket to get something created. So especially in the beginning, when we started with Kafka, there was no such a thing to manage this. So that's something we built ourselves. We're quite proud of, and it's still around. Some numbers. It started really small, but on average we are processing almost. We already crossed 1.2 million messages on average a second. So you can imagine that Kafka is a quite big nervous system for ING. If Kafka is down, then the bank is down. We are really keen in keeping this stable as possible. And the traffic is still growing at 10% every month, roughly. And with the upcoming Christmas period, Black Friday period, right? It's only increasing. So we have to keep this stable. Enough about ING. Let's see what we're covering today. I don't know how many of you are using Kafka, know Kafka. Maybe some hands for me to. Okay, that's nice. I also see some people that didn't raise their hand. That's fine. This is not about teaching Kafka, right? But at least you need to know a little bit about the basics to also follow the demo and the slides I'm talking about. So that's what I would like to cover first. Then we going into observability, about the 3 pillars of observability. And then I have a demo about client-side metrics and how to interpret them and also compare them with broker metrics. And we had some interesting support case with some people that are using those metrics, and they were really puzzled. So I would like to share that today. And then we're also going to focus a little bit on OpenTelemetry in combination with Kafka, quite interesting. And we also have a demo there. So we see how events are flowing through a relatively simple distributed system and how we can see where things are going wrong. So there is a demo for that as well. So we then cover basically distributed tracing, logging, and metrics in one go using OpenTelemetry. Then it's time to wrap up, and let's see if there's time for questions. And otherwise, we can always catch up during the drinks. Okay, in a nutshell, we need a broker, right, to store it. Kafka is an event streaming platform, so it's not your typical message queue. You can use it or app use it as a message queue, that's fine. But the idea is that we process events or messages when they're coming in. So we don't want to do batch processing, which of course have their places, right? But the idea of Kafka is streaming data and handle data when it comes in so we can react as quick as possible. To store all this data, especially on the scale of ING, we cannot live with one single broker, right? It's just way too much data, so we have different clusters and different brokers that are together, working together as a cluster. And in those clusters, we have topics, and a topic is basically a logical name for something you store in Kafka. In the examples, we will talk about stock quotes. So we are mimicking the stock markets, that trades are happening. And actually now my machine is already producing quite a lot of data for the first demo, but this is just an example of a topic. If you're not really into Kafka, it's also really good to understand that a topic consists of multiple partitions, because, for example, stock quotes, they're coming in like 20,000 a second. We cannot keep that all in one machine, so we need to partition, split that over the cluster, and we have multiple partitions. Then we have producer applications that are basically producing data to Kafka. Data will end up on the different partitions, the producer is basically responsible for sending the data, serializing the data, because all the data stored in Kafka are just bytes. That's why Kafka is super fast and can scale really, really good. And then data comes in on different partitions. And then, of course, that data will be sticking around in the Kafka topic. The default is 7 days, and after that, the data will be gone. And then consumers can consume that data. They can basically subscribe to the topic and do basically the reverse. So they get the bytes in and they deserialize the data into a Java object. In this case, because all the examples I'm running are built in Java, of course. And they also send heartbeats to the broker, so they still say, I'm alive, right? I'm alive, so I'm there. And of course, you can also scale the consumers up to the number of partitions. We will see that in the demo as well. And if you have more consumers, that will make sure that there is a standby, and Kafka will take care if one of the consumers die in that group, then it will basically do a rebalance and make sure it keeps consuming. Next to that, it's also good to know that Kafka itself doesn't really care about your objects, right? Everything are just bytes, so it is not responsible for type checking or schema validation. There you have the schema registry, but that goes maybe a bit too far for this talk. But it's not, responsible for those kind of constraints, and everything is stored in bytes. In the example, we also have a Kafka Streams application, and a Kafka Streams application is basically an application you can build to do stream processing. So you can get data in from multiple topics, maybe join data, push it out to another topic in near real time. So you can all do kinds of fancy stream processing operations there. I think that's the basics of Kafka. There's way more, but there's just no time to go into it. But I think this is the bare minimum you need to know to follow also the demo and the examples. Let's go then into observability. And this is, I think, the official definition we found on Wikipedia. And it says that observability is the ability to measure the internal state of a system by looking at its external outputs. And those external outputs, we probably all know, are the logs, the metrics, and the traces. And because probably most of the application you and we are building are distributed, so we talk about distributed tracing during this talk. probably it's quite obvious why we need this, but I think it's fair to say in the last 10 years, we moved more from monolithic style applications into microservices. We have multiple databases, multiple interactions between services, the rise of Kafka as maybe your event-driven backbone or event bus. It's all nice, but it also makes our lives, I think, not easier, especially also looking at all kinds of centralized logging systems, monitoring systems. They scream for your attention, right? Which one to pick? And at some point, some different standards came up, and that's what we're going to talk about in the OpenTelemetry part of this talk. So basically, it boils down to we need to observe our systems and be able to act when needed. So it helps us to investigate root cause incidents. It's also nice because it also helps us to improve our software, right? We can change some settings in Kafka, see what it does. We probably don't even have to deploy to an environment, but we can tweak around with it, right? So also this observability helps us to build better software. In the end, of course, we need to prevent outages, and we all build software for our end users, so we also would like to have a nice customer experience, and if it's going wrong, we should be able to act quickly. Then the 3 pillars of observability. The first one is logging. We probably all remember the first time we wrote this Hello World application in Java and wrote something to the log or to the console. And this is the bare minimum you need as a developer, right? So logging is all about recording individual events of data that makes your life a little bit easier in case you need to investigate something. And it helps you to understand what happened at that line of code, but it doesn't really help to show you the broader context, right? It doesn't tell you how many messages were produced to Kafka, how many customers have a good experience with your API. That's something you not get out of logs. So that's where metrics are coming in. And metrics are recordings of time series data. And it's more of an aggregate over the data and the metrics. So an example is how much I'm lagging behind on consuming from a topic. What is the average response time? This is all about those kind of metrics, and it helps us to better understand the context, what's happening from an aggregate, and it also helps to identify trends, and of course we should also alert on it if something is going off. It's nice that we have those metrics, but if something is off, we still don't know exactly where in the chain it might happen, or why is it not working? So then the third pillar comes in, and that's basically tracing or distributed tracing. And that's basically all about recording the flow through your distributed system. Can be REST calls, but also in this case, specifically on Kafka, how an event travels through a system. And it helps you to understand why something happened and also how much time is spent. And we will also see that in the demo. I will share the slides afterwards, so don't worry. We're all Java developers, right? So I think you know what Spring Boot is. All the examples I built, I also will share the code base with you. It's on my GitHub, so you can play around with it afterwards. But it's, I think the default factor standard of building Java applications is, of course, really opinionated, and you build your fat jar probably into a container in the end. And it also has some nice production-ready features that are brought to you or available for you using Micrometer. And that's basically what I'm going to show also in the demo. So how many people are using Micrometer, are aware of Micrometer? Okay, a fair amount, okay. It's there by default. It's the default metrics facade. It even supports tracing now in Spring Boot 3. And it's a really nice library that is aimed to be a vendor-neutral solution for observability in your Spring Boot applications. You don't necessarily have to use it with Spring Boot. You can also use it in a normal old-style Spring application. It's not something that you can only use with Spring Boot. But you can think of Micrometer like SLF4j, but then for observability. So you have just one API to talk to. and you plug in a certain dependency, for example, to ship data to Prometheus, to have an endpoint to be scraped. And it's basically focused on metrics and traces. It also provides you with an API, so you can instrument your own code with that API and then use that. The nice thing, it is used by a lot of Spring projects. So in the example I will be running during the demo, we're using Spring Kafka. And all the Kafka metrics will be out of the box exposed for you. And it also supports around 90 popular monitoring systems. Yeah, I already touched on this one. And just to give a little example, so we focus on the consumer application for the metrics demo. And yeah, it will consume, of course, from Kafka. And we have the Spring Boot actuator. You probably know about this. This is the actuator from Spring Boot. So it gives you health check information, information about your application, but it also can expose a metric endpoint, yeah, using the actuator/metrics. And this is an agnostic one. And if we drop in the Micrometer registry Prometheus one, there will also be a Prometheus endpoint, and the metrics are already there out of the box for you to be scraped by Prometheus, and we can have a nice dashboard on top of that. If you're not on the Prometheus stack, but you may be using Kibana and Elastic for your metrics, which is possible, then you replace the Prometheus one by the Elastic one. And of course, you need a little bit of configuration because this is a push mechanism, and it will push basically the data to Elastic, and you can have your dashboards in Kibana. So without changing your actual code, you swap out the underlying library, and you can basically migrate to another observability system. Since Spring Boot 3, there is also support for OpenTelemetry, which is quite interesting. It's not that mature yet, but it will improve version by version, so that's also in the code base. Yeah, I would like to work towards this demo now, because I feel my machine is already heating up a bit. If you're into Kafka and you're a consumer of data, you would like to consume the data as fast as possible, right? So one of the most important metrics to measure in a Kafka consumer application is the consumer lag. And the consumer lag basically tells you, hey, the producer produced already 1,000 messages. So we call that an offset in Kafka. So the producer is at just produced message 1,000, but the consumer is still consuming. It's reading from the topic, and it's at a point offset 400. So basically, yeah, the difference between where the producer is actually producing and your consumer is, yeah, hopefully not stuck. That's basically the lag. So you're lagging behind 600 records. And if this keeps growing, yeah, you're not real-time handling data. And if this takes too long, and even after 7 days, you might not be able to catch up. You might even not able to read those events because Kafka, after 7 days, will remove the data. You can, of course, configure Kafka to be an infinite store, but that's up to you. That's not the default. So this is, in ING, a really important metric to look at. Of course, we're all building great applications, so we never have consumer lag. But for the demo, I made something up to artificially generate the consumer lag. So we have the broker, we have a producer that's producing stock ticks to a topic. So we're mimicking the stock markets, and we have a consumer. And this consumer will call another service over REST. And this REST API is a bit buggy, it's a bit slow. And basically, make sure that we have a consumer lag on the consumer, because it can basically not catch up, because calling that REST endpoint and handling that takes more time than the producer is faster, basically. So we create a lag. Then we have Prometheus, of course, with Micrometer. We scrape that endpoint, and we have a nice dashboard on top of that. And we also have, I think this is quite common in the Kafka world, that you can also generate lag metrics on the broker side. And there is a piece of software that's called a lag exporter. And that will basically, on the broker side, create those metrics. And so we also will scrape the metrics. So we have the consumer side metrics, and the lag metrics from the broker, and we will compare that. Because we had an incident with a team that really had huge differences between the client-side metrics and the broker-side metrics, and initially we could not explain why this happened. So we have a nice dashboard to show. So let's go to the demo. Okay, is it visible in the back? Otherwise I'll make it a little bit bigger. So on my machine I'm running in Docker, quite a lot of stuff already, but we have Kafka, we have a consumer, a producer, Kafka Streams application, and we also have a plain Java consumer to not use Spring, because we also would like to see how the messages are flowing there. So this is the consumer. We can basically quickly check the dependencies, and here we see we have Micrometer in there. Of course, we have some Kafka libraries, and here we see we have the Prometheus one. So it will expose this endpoint for us, and we can go to Grafana now. Okay, all good. Let's zoom out a little bit. Let me explain. On the left side, we see the client-side metrics. So the application is consuming. Maybe I should also show you a little bit the topic and the data that's flowing. So we have just one Stockwell topic in our cluster, and we already produced more or less 130,000 records. That's fine. And on the right side, we see the metrics calculated basically from the broker side. And you already see the number on top. It's a huge difference, right? So the team thought, okay, 4,000, 20,000, it's not that bad, right? Maybe we can catch up. But actually, the real lag was already more than 100,000. So at some point, they were afraid that they were losing messages on Kafka because they could not keep up. But looking at the metrics, they thought, okay, we were quite okay. So what is actually happening here? We are consuming with one instance. So we have 3 partitions. And this application is basically, you see it also in the line, you see the partitions have a nice color. It starts consuming from one partition, then switches to the other one, and it's basically going up and down. But the trick here is that only the partition that's actively consumed will generate the metrics. Since this application is sort of single-threaded and is only consuming from one partition at the same time, it will only report 1/3 out of the metrics. And there is also, not in every partition, there is an even amount of data. So it can be really confusing if it switches to another partition and then it might be going up or down. So compared to the broker metrics we have on our team, we saw really different numbers. So we start investigating. We even had contact with Confluence, the company behind Kafka nowadays, and we were really puzzled. So at some point we thought, okay, let's start more instances, right? So let's start 2 more of the same application. It takes a little bit of time, and let's see what happens. So to explain, we are running now 3 instances. They are basically what we call in Kafka working together in a consumer group. So they're a family with the 3 of them consuming the same topic. And every application, every instance will consume just one topic. One partition. So now we have 3 instances. They are all 3 consuming one partition. So they will be exposing also the metrics for each partition. So if we give this a little bit of time, you will see that the number is going up quite fast already. If we give this, let's say, a minute or so, then it is almost the same to the number from the broker. So this was really in the beginning a puzzle. They just had one instance, multiple partitions, even more than 3. This was really a nice lesson learned for us. While it's catching up, maybe I can show you how Prometheus is scraping and how the metrics are exposed. So Micrometer doesn't only care, of course, about Kafka metrics. It gives you JVM metrics. It gives you, if you have a database, you have database metrics, but this is a Kafka-only application, so we have a lot of consumer metrics, Tomcat metrics, and those are basically available under the Prometheus endpoint. And those metrics are then translated into the Prometheus format so we can scrape it. You don't have to do anything for this. Yeah, while I'm talking, it already sort of catched up. It's not there yet, but it's way closer. So that was basically a hard lesson we learned during one of our sessions. So to summarize, right? We started with one instance. It gets the offset and say, hey, this is the point you have to work to. Then you see it's going to consume the data, works towards that point. If there is a higher lag, so the lag keeps growing, it also doesn't switch that often between partitions because also that takes time. And actually the consumer is not aware of the next offset. So then at some point it switches to the other partition. The producer doesn't stop, right? Because they're completely decoupled. And the actual offset grew already in the meantime. And the consumer is just not aware of that. So the lessons learned and the takeaway about metrics for this Kafka Java application is that the exact precision of the metric should not be something super critical. We should monitor the trends. Of course, it's important to know that there is lag, and if the lags is keep increasing, we have a problem because at some point we can just not keep up. And a consumer has a problem, and you either have to scale or do some other things to solve this. And of course, we have to alert on this kind of cases. So, we probably all know logs, right? So we covered metrics. I think it's nice to now look into distributed tracing. We are migrating to OpenTelemetry, which is becoming more and more popular, and you see it probably in a lot of spaces, and I think it's a real thing. So let's start what is software telemetry, and then dive into OpenTelemetry. It's basically the collection of data on the use, the performance, and the behavior of your applications and their components. And at some point, there were basically two competing standards. OpenCensus, that was focused on distributed tracing and metrics, built by Google, and OpenTracing, built by Uber, if I'm not mistaken. And at some point, there were two competing standards, and it was not helping to integrate between systems and companies and providers. And they decided to work together and basically merge this into OpenTelemetry. And also they aimed to make a migration more easy. So people that are using OpenCensus or OpenTracing should be able to relatively easy migrate to OpenTelemetry. So we also, for the Kafka part, start investigating what is needed to do this. But before we dive into the demo, maybe it's good, if you don't know OpenTelemetry, of what components it basically consists. So there is an API, it's basically a specification. But the API defines the interfaces for instrumentation. And there is an SDK basically for a lot of languages like Java, Python, C++, etc. And that those APIs and SDKs you can actually use in your application to manually instrument your code. And there is also a protocol that is basically responsible for encoding, transport, and delivery of the metrics to a observability backend. Can be Grafana, can be Prometheus, where you can basically store it. So that's basically all about shipping the data. You can even ship it to Kafka as some kind of a buffer. That's quite heavily used also in ING to decouple the actual applications from the monitoring systems. And it's good to know that OpenTelemetry itself doesn't provide you with tools to show the data, right? They're already around, like Jaeger, Zipkin, Grafana Tempo, what have you. And there is also an optional component that's basically called the OpenTelemetry collector, where applications can basically ship their telemetry data to, and the collector is responsible for basically shipping that to the actual storage backend. But we will talk about that a little bit more in the upcoming slides. So you have basically a couple of options to either instrument your code using the library. You just have to use the APIs to generate traces and metrics. Or you can choose an agent, to attach an agent, and that will basically start with your application, a typical Java agent, and will generate a lot of this data for you out of the box without manually changing your code. And then the data will be shipped to the observability backends. Let's talk a little bit about the collector then. So you can see this as a sort of a sidecar that can run next to your application. It can receive telemetry data. It can even be open tracing data that comes into the collector. It's transformed into OpenTelemetry format and then further shipped. So this is a case for where you can use it for migrations from, let's say, open tracing to OpenTelemetry. But it also has a lot of processors. You can filter out data. You can buffer data and then ship it to a backend using exporters. And there are different exporters you can configure. You can ship it to Kafka or any other system. So in the demo, I think we are using the same example with the stock quotes. In this case, we also have a streams application. So this is still the same like we had in the metrics demo. And we have a Kafka Streams application. It's a super simple one, but it will consume from the stock quote topic. And then based on the stock exchange where the trade happened, it will basically branch it off to a topic. So it can be the New York Stock Exchange topic or the NASDAQ one or the Amsterdam Stock Exchange. It's simple, but it's basically consuming from the topic. Say, okay, it comes from this stock exchange, and then we'll push it right away in real time to the other topic. And we also have this plain consumer in there, and they will all work together and will all use OpenTelemetry. So in this case, we're using the agent attached to the process, to the Java process, and we'll all start shipping the data to the collector. And we will ship the logs, the metrics, and the traces to Kafka. We also can scrape the collector for Prometheus metrics. We will ship the logs to Loki. In this case, it's a centralized logging system from Grafana Labs. And just to emphasize that you can basically switch between backends using the collector, we ship it both to Jaeger and to Tempo. So without changing your application, you can basically, using the collector, change a backend, which is quite powerful. So let's go into the demo. Okay, that's not nice. Let's see. Okay, I think my Docker crashed a little bit. Let's see if we can fix that right away. Yeah.
Out of curiosity, how much RAM do you have on your computer?
Yeah, quite a lot, but during the Kafka Summit, everything went fine, but it's always, let's see if we can have the activity monitor. It doesn't take a lot of time to start, but it's quite heavy. We should have, no, let's see if we can just start Docker again. Okay. In the meantime, we can maybe take some questions while Docker is starting. Yeah, because it's running Kafka, it's running the schema registry, it's running 5 Spring Boot applications, the Streams application, the consumer, the plain Java application, Loki. It's basically, yeah, quite a lot, but normally it worked. Okay. Let's see. Yeah, okay, it's starting. Yeah, so what we're going to do during the demo, I disabled generating a lot of data, right? Because then it becomes even more heavy. And also because I would like to show you how an event travels through this small distributed system, I exposed a little endpoint so I can call that, and that will put an event on Kafka, right? So we can just control yeah, how the data is flowing. And of course, I also accidentally introduced a bug in one of the services. I don't know, yeah, I know which one it is, but we're going to figure out where that happened. And for that, I also need to send a stock quote that has a certain criteria. Let's see. Sorry for keep you waiting. I would like to be sure that everything is running, because otherwise the demo will probably not work. Okay. Okay, we're almost there. But that's always the tricky part with live demos, right? You never know if it's working. Yeah. Okay. Let's see. Yeah. So we have more topics now. Those topics are basically the topics for OpenTelemetry. So the logs will go into a separate topic, the span will go into a separate topic, and I think we also have the traces at some point. And of course we have the stock quotes, right? So we will produce one and it will be branched off to one of the topics. So that's working fine. Let's see if, yeah, okay, everything is fine. So this is the small exposed API for us to generate a stock quote. And let's first do the, yeah, let's say the happy path scenario, right? So we would like to see how it's flowing. So this is demo 2. And we have a small JSON payload, and we say, hey, we have an ING stock for a certain price. It's traded on the Amsterdam Stock Exchange, and let's execute this. So we can, let's do it 2 times, so we have a little bit of data there. So data came in on that topic. Let's maybe show a conductor. That's a nice view on top of Kafka, so you can see what's happening. So we produced 2 stock quotes. They were both traded on the Amsterdam Stock Exchange, so they ended up here in this topic. And now we would like to follow this event through the whole chain. So we can go into the log of the application. So let's take a quick look here. I hope it's big enough in the background. And if you're working with distributed tracing, there are basically 2 important things. One is the trace ID, and the other part you see here in the log, so we can correlate this, is the span ID. So the trace ID is basically a unique ID for every journey through our event-driven system, and every application where the message has been consumed to will be having this unique span ID. So yeah, we can look up this number in the consumer application, because the consumer application consumed the event. So it's here, but the consumer also called the REST API. So we can even go into the shaky downstream service, and we can also look up this trace ID here. The same goes for the plain Java one and also the Kafka Streams application. yeah, we can all see it. But of course, we don't want to log into machines and capture all the logs. So of course, we will have a central logging solution. And for that, we have Loki. We see all the components. We can see all the logs. And of course, we can check the trace ID. And yeah, it's all there. So it's basically the same view, of course. But now the interesting part is basically the distributed tracing. So for that, we have Tempo. It's a nice tool. And we can basically say, I would like to see this trace ID and run the query. I don't know if it's big enough. But yeah, all this data is basically generated with the OpenTelemetry agent. And we can go into each and every step of the process. So the producer produced the data at the REST endpoint. You have a lot of attributes. You have to be careful what you ship, right? Because maybe it's way too much. But you see a lot of details about the HTTP target we called. And at some point, all the way down to all the other services. And it's also nice, you can see where time is spent, basically. So that's nice. But I also promise you to show the same view in a different tool, also based on OpenTelemetry. So we also have Jaeger. It's a similar tool for distributed tracing, and we can have the same view here. It looks a bit different, but it's really based on the same OpenTelemetry data that's around. And I think you can even have a nice, sort of graph. So how you can basically see how components are interacting with each other and how many messages were basically pushed down over Kafka topics, which is, yeah, I think quite nice. But so far so good, right? We're here for breaking stuff and killing Docker containers. And so, yeah, let's call the same endpoint, but now we are basically having a payload that will break some of the components. So yeah, the symbol is kaboom. And yeah, let's see what happens. So we can execute this call. It will generate a message from Kafka, and something broke. In Tempo, we can, let's see, also make queries. So we can basically say, this is a super simple query, but we would like to see all traces that have a status error. And it already shows us, hey, something happened. For this trace ID in this call, yeah, something went wrong. So we can see the same, let's make it a little bit bigger. It's a sort of the same view. And you can see that apparently the consumer was not able to, yeah, it received the event, but it was throwing an exception. And we even see that it did that 10 times. That's the default of Spring Kafka. It will try 10 times to handle that message, and otherwise, after 10 times, it says, I'm giving up, and that message is sort of lost. But the nice thing, you can see all the details, but I think it's super interesting to see also the exception. So let's see if I can show that here. I should be. This is the plain consumer. I think it's here. Yeah. So we can basically correlate this to the logs, and in the tracing view, we even see the exception that was thrown in that service. So I think this is a really powerful thing. And of course, the same thing, you can see it in, you can see it in Jaeger. Yeah, I think that was the demo for the distributed tracing. So I think it's time to wrap up. Is it working? I think it will kill Docker again, sorry. Okay, let's see how long this machine keeps up. But anyway, even my, let's stop it because I think just a little bit too heavy. Okay, come on. It's still, yeah, I don't see it, but yeah, like I showed, there are many different ways to observe your application. We aim for a vendor-neutral solution. It helps you to migrate if you need to switch observability backends without minimal changes in your applications, like we saw with the OpenTelemetry collector, which is an optional component. We saw Micrometer in action. There is a lot of overlap with OpenTelemetry. It can even integrate with OpenTelemetry, but it's JVM only, right? And there are also some things that don't work yet. So, for example, there's no instrumentation yet for Kafka streams. Especially on the traces, this is a bit problematic. Yeah, you can send data to OpenTelemetry. And it's focused only on metrics and traces, so not on logging. Yeah, we saw the consumer lag in action, the client-side metrics versus the broker metrics. Yeah, the takeaway is to monitor the trends and yeah, also make sure you don't ship too much, right? Because we saw this huge list of metrics. If you have more frameworks, this list of metrics will only grow. So pick only the metrics you need. You don't know what you don't know, but you can always enable more metrics if you need. OpenTelemetry, I think it's super interesting. There's a lot of traction in OpenTelemetry, and it's really language agnostic, so you can use it with Java, with Python, with many languages. Yeah, in our case, we started small. We started with the agent because we didn't have to instrument our applications right away just to get started with it. So it gives you a kickstart to use the agent, yeah, without spending too much time. Also sample your traces, right? Now we shipped all the traces during this demo to the backend, but if you're on a scale like ING, that might be a bit too much. So that's called basically sampling, not recording all the traces. So yeah, it also costs money, right, to store that. So that's also something to keep in mind. And of course, also with OpenTelemetry, there are still some limitations around Kafka stream processing and handling that. Yeah, and like I said, the code base is available. So if you would like to play around with it, you can also use something else than Kafka, right? But at least the whole setup is there, so might be nice. Yeah, if it went maybe a bit too fast, then the recording of the Kafka Summit is also available. And I think they're even going to publish the video of this meetup. So we will share that via Roy. Yeah, that was my talk. Okay.